Alright, let's look at the homework 7.8, 7.9, problem number 5. Alright, let's evaluate this double integral. Alright, so since we're taking the antiderivative with respect to x, this is actually a constant. So we can actually write it as, right? So we can kick this constant outside of the inside integral. So it's going to be integral from 0 to 1, then square root of 1 minus x squared is outside. Then we just need to evaluate this integral from 0 to x. Right, so it took it out, so it's going to be, you can put 1, but you just have a dy. Right, and then dx. Alright, so the inside integral is very easy to integrate. So square root of 1 minus x squared is still there. Alright, then this is going to be a y. And because antiderivative of 1 with respect to y would be 1. And it's going to go from 0 to x dx. Alright, so if you plug in x here, you're going to get x minus 0, so you're just going to have x. So you have an integral from 0 to 1, square root of 1 minus x squared times x dx. Alright, so let's use a substitution here. So I'm going to let u be expression inside the square root. So it's a 1 minus x squared. Right? So go through the usual drills. Take the derivative of u with respect to x, which is going to be equal to negative 2x. Right? Then take the reciprocal of both sides. So basically we just put it upside down. Dx over du is equal to 1 over negative 2x. Alright, then multiply both sides by the denominator du, so that we have expression for dx. So dx is equivalent to du over negative 2x. Alright, so we can rewrite this. We decided to call the expression inside the square root u. So this is going to be integral, right, square root of u. And I'm going to leave this x as it is. Right, dx is the same thing as du over negative 2x. Right, then we have to do convert the lower limit and the upper limit. So originally x goes from 0 to 1. Right, now u, corresponding u values are, plug in 0, so 1 minus 0 would be 1. Then 1 minus 1 squared would be 0. So you're going to go from 1 to 0. Right, and if you want, since there's a negative sign here, so use this negative sign to switch the lower limit and upper limit. So you have a 0 here and 1 here. Right, so we're going to have integral, right, from 0 to 1. Right, so there's a 2 here, so it's just a constant, so put it outside. Right, I don't like square root, so I'm going to write it as a u to the 1/2 power. And also x on top and x on the bottom is canceled out, so all you have is just du here. Alright, so take the antiderivative of this. I'm going to actually go up here, so there's more room here. Alright, so it's 1/2 is still there. And integral, actually, we can find antiderivative. So antiderivative of this guy would be add 1 to the power. So it's 3/2 power. divide by 3/2 is equivalent to multiply by 2/3. Then you're going from 0 to 1. Right? So we can cancel 2 on the bottom and 2 on top. Right? So what we get is, right, 1/3 times 1 to the 3/2 is 1 minus 0. So it's going to be 1/3. Right? So this is the value of the double integral. Right? So let's type it in. Alright, so the value we got was 1/3, so 1/3. Alright, so let's submit for testing. Alright, it came back and it looks like we got this one correctly. Alright, that's it. I hope that this was clear.